All right, let's graph some cosecant graphs. So as we take a look at this, we want to first graph -3 times the cosecant of 4 over x. And you may recall that cosecant is the reciprocal for sine. So because sine starts at the origin, goes up, comes back down, and ends up at the origin, what's going to happen on this graph is we're going to get a vertical asymptote whenever sine equals 0. So a vertical asymptote at the y-axis. And then just kind of splitting this apart. Remember, sine goes up, gets back to 0 here at pi. Normally that's pi, but in this case, it's going to have changed a little bit. Comes down. Normally sine gets to -1 and then comes back up and it ends at the origin again. Wherever the sine graph is going to be at the origin, cosecant is going to receive a vertical asymptote at those same values. All right. The next thing to note is we have this -3 out in front. So what this -3 is going to indicate for us is it's kind of like labels on our y-axis. We have +3 and -3 going on. Those be the labels on our y-axis and kind of where these loops either come down to or come up to. Now, in this case, this has been reflected vertically because we have this negative sitting out in front. So instead of our sine graph that normally starts and comes up here, has a highest point at +3. If our sine graph was flipped upside down, it would come down first, then come back to the origin, then go up, come back to the origin. So this is going to produce a point at the bottom in between those vertical asymptotes and a point up here above the x-axis between these vertical asymptotes. All right, last thing we need to worry about is labeling our x-axis so we get the exact right labels going on throughout. So to do this, what I always like to do is just go back to the period for cosecant is normally 2 pi, just like it is with sine, cosine, secant, and cosecant. And then you're going to divide this by whatever multiple we have on the inside. So in this case, it's going to be divided by 4. With a little reducing down, we can see our total period is going to be pi over 2. Also of note on this one, it hasn't been shifted left or right because we don't have a number added or subtracted from x on the inside of this function. And it hasn't been moved vertically up or down because we don't have an addition or subtraction attached to the entire function. So to kind of sketch in this graph, I know it goes down this direction, goes down this way, and then we kind of have this loop that has a bottommost point right there and goes up as we approach the vertical asymptotes. All right, so let's label the x-axis. We know that it has a total period of pi. So this one starts at 0, ends at pi over 2, I should have said. Let's label that middle vertical asymptote. That's going to be halfway in between. So half of pi over 2 is pi over 4 for that vertical asymptote. This highest point is going to be halfway between 0 and pi over 4. So I guess that's half of pi over 4 is pi over 8. And then one more label here. This bottommost point on this section of the graph is going to be halfway between pi over 4 and pi over 2. So I believe what we have there is 3 pi over 8. All right, now that we have all of our labels, we've got a pretty good graph going on. Let's leave this one like that and move on to the half of a cosecant of 2x. Very similar process on this one. Difference though, this one has not been inverted. It's not flipped upside down. So I'm just going to kind of sketch in our vertical asymptotes. And then this is going to be our traditional cosecant graph that hasn't been flipped upside down. So this first loop kind of comes down, has the lowest point, then goes back up. While the second loop has a highest point and goes down as it approaches these vertical asymptotes. Not perfect, but go with it. All right, these labels on the y-axis, those come from this compression factor in front, so 0.5 and -0.5. We are labels for this, the y value of this point and the y value of this point. And the last thing to concern ourselves with is labels on the x-axis. So again, this kind of goes back to the period that I usually start out and just say, well, it's normally 2 pi. I'm going to divide by that multiple on the inside, this 2. With a little reducing down, we can see that's going to work out to be pi. So that means this is going to start at 0 end at pi. Halfway there is pi over 2. Halfway between that and 0 is going to be a fourth of a pi, so pi over 4. And then halfway between a half a pi and a whole pi is going to be 3 pi over 4. 3/4 of a pi is between half of a pi and a whole pi. All right, so we got all of our labels, got a nice sketch of this graph. I hope this helps out as you're working on these problems, trying to get nice graphs of cosecants.